A certain city with population of 132,000 is to be divided into 11 voting districts. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 voting districts, and the total population of all these cities is equal to 132,000. And no district is to have a population that is more than 10% greater than the population of any other district. So it's a very important line which basically ensures that the highest populated city cannot have the population more than 10% than the population of the lowest populated city, right? So if the lowest populated city is equal to x, then the highest populated city cannot have a population greater than 1.1x. That's the maximum population of any city can have if the least populated city has a population x. Now the question is, what is the minimum possible population that the least populated district could have? Now it's a very beautiful question. It's an official GMAT prep question, and it requires us to calculate the minimum possible population of the least populated city. That means we have to find out the minimum possible value of x. That's the question. Now, in the questions of maximization and minimization, there is one thing that's always constant, and that's what I want to discuss with this particular question. For example, if somebody has the salary of $100, right? So the income, when somebody gets an income, then it is divided into two primary parts. One, the expenses, and the second is the saving, right? And we can say that saving plus expenses is equal to the total income. Now I'm just taking a hypothetical question that, for example, for someone the income is $100. Now if somebody wants to maximize the saving with fixed income $100, then what does the person has to do? Then the simple answer is that the expenses needs to be minimized. This is the entire concept of minimization and maximization. When the summation of several numbers is fixed, then if you have to maximize one thing, then everything else needs to be minimized. Similarly, if something needs to be minimized, then everything else must be maximized. The same logic is going to be used in this question as well. The question here asks that what will be the minimum possible value of x. That simply means that every other place must be maximized because their summation is fixed 132,000. Now the question is, what is the maximum possible value that can come at this place? Now we know that if least populated city has population x, then the most populated city cannot exceed the population 1.1x, which means if you have to maximize every other term, we will say that every other term is 1.1x because that's the maximum value that every other term can take. Remember, when I write the numbers like this, I always try to write them in increasing order. So all these numbers here are 1.1x. Now we have 11 districts. That means one district has population x, the other 10 districts have population 1.1x, and the summation of them is equal to 132,000. And we have taken it with respect to the logic that if one thing needs to be minimized, then everything else should be maximized. Now we simplify it. X plus 11x is equal to 132,000. That gives us 12x is equal to 132,000. That gives us x is equal to 11,000. So now we know that the minimum possible value of x will be 11,000, and therefore the answer should be option D. I hope you enjoyed this explanation, and remember, the maximization and minimization rule is entirely based on the same example that we discussed here. Thank you so much.